On September 18, 2025, China made a seismic move in tech. It told giants like Alibaba and ByteDance to stop buying Nvidia's AI chips. For years, Nvidia's GPUs powered China's AI boom. Now China is saying, we'll build our own. This isn't just about hardware, it's about technological independence. Beijing believes its domestic chipmakers like Huawei are ready to compete on the world stage. The ban signals a new era. China is betting it can lead the next wave of AI without American tech. For Nvidia, it's a massive market lost. For Chinese tech, it's a forced pivot to homegrown solutions. The global tech ecosystem is fracturing. The era of a single, interconnected digital world may be ending. We're entering a phase where parallel tech spheres, each with their own hardware and standards, could emerge. This is more than a trade dispute, it's a fundamental shift in global tech power. China's move is both a response to years of sanctions and a bold play for leadership. The decision to cut off Nvidia is the clearest sign yet of China's ambition to become the world's AI superpower. The stage is set for a new, intense era of global tech competition. China's ban didn't come out of nowhere. It's the latest escalation in a tech Cold War with the US. For years, the US has tightened export controls, aiming to slow China's AI and computing progress. Nvidia's most advanced chips were first restricted, then nerfed versions were allowed, until the rules got even tighter. Each new sanction pushed China to realize relying on US tech was a vulnerability. Instead of crippling China's AI ambitions, US sanctions supercharged its drive for self-reliance. Billions poured into domestic chip development, and every restriction reinforced Beijing's resolve. The 2025 ban is the culmination of this multi-year strategy. It's not just retaliation, it's China breaking free from American tech dependency. The tech Cold War has redrawn the global innovation map. For Nvidia, China's ban is a financial earthquake. China once made up 17% of Nvidia's revenue, billions lost overnight. Even before the ban, Nvidia's market share in China had dropped from 90% to 50% as local competitors improved. Now that number will likely hit zero. Nvidia's leadership admits they're caught in a geopolitical crossfire. For Chinese tech, it's all hands on deck to build a domestic ecosystem. The loss isn't just revenue, it's the end of a feedback loop with some of the world's most innovative tech companies. China's pivot could eventually create a global rival to Nvidia. The immediate impact is financial, but the long-term consequences could reshape the entire AI hardware landscape. The world's AI race just got a new front. China's confidence comes from real progress in domestic AI chips. Huawei's Ascend series, especially the Ascend 910, now rivals the export-limited Nvidia chips. Chinese chipmakers plan to triple AI processor output in a year, aiming to fill the Nvidia void. Tech giants like Alibaba and Tencent are designing custom chips, fueling a competitive domestic market. China's AI research output now surpasses the US, UK, and EU combined. Top universities like Tsinghua and Peking drive innovation, feeding talent into industry. This synergy of hardware and research means China isn't just copying the West, it's starting to lead. Chinese companies can now build AI models tailored to their own chips, creating a fully optimized ecosystem. The rise of Dragon chips is about more than replacing Nvidia. It's about setting new global standards. China is building a parallel AI universe on its own terms. China's workaround for lagging chip tech? Clustering. Instead of one ultra-powerful chip, they link many domestic chips to work in parallel, like using a fleet of engines instead of one giant one. Massive server racks filled with Huawei, Ascend 910S create distributed supercomputers. The focus shifts from raw chip power to system design and software optimization. Chinese firms are becoming experts in networking and distributed computing. This approach is cost-efficient too. DeepSeek's R1 language model was built with less investment using clustering. It's a pragmatic solution that turns a manufacturing gap into a systems advantage. By mastering scale and architecture, China is building world-class AI infrastructure its own way. This strength in numbers strategy is a long-term asset, regardless of chip manufacturing advances. China's engineering focus is shifting the rules of the AI race. Nvidia's real edge isn't just hardware, it's CUDA, the software platform that powers AI development. CUDA's ecosystem locks in developers, making it hard to switch to other chips. China's ban forces it to tackle this software challenge head-on. Building a CUDA alternative is monumental. It means new tools, libraries, and retraining thousands of engineers, but it's also an opportunity. China is investing in open, hardware-agnostic AI software. If successful, this could break Nvidia's software monopoly and accelerate open standards. Chinese tech giants and universities are already collaborating on new frameworks and translation layers. The transition will take years, but it could reshape the global AI software landscape. The future may be one where AI code runs on any hardware, not just Nvidia's. China's forced innovation could open the door to a more open, competitive AI world. There's one more challenge: energy. Training massive AI models eats up staggering amounts of electricity, thousands of megawatt-hours per model. China's chip clustering strategy, while clever, is less energy efficient than using a few advanced chips. More chips mean more power draw and higher operational costs. This strains China's power grid and clashes with its carbon reduction goals. The government faces tough choices: build more power plants, invest in green data centers, or develop more efficient AI models. Energy constraints could push China to lead in green AI innovation. Models like DeepSeek R1 already focus on efficiency. The winner of the AI race may be the country that solves the energy puzzle, not just the chip puzzle. For China, managing AI's energy appetite is as critical as building the chips themselves.